The James Webb Space Telescope is set to revolutionize our understanding of the universe. And one of its key targets will be the clouds on Saturn's moon, Titan. Titan is one of the most exciting worlds in our solar system. NASA's all-powerful James Webb, along with the Keck telescope in Hawaii, have together captured Saturn's moon in infrared. On top of this, scientists were even able to track and study the clouds on Titan, aiming to map the distribution of different gases in its atmosphere. So how was James Webb able to make these observations? Why is the observation of Titan so important? And what answers were we looking for? In this video, we will talk about all of that and more. Titan is known for its thick atmosphere and its methane-based hydrological cycle, with liquid methane and ethane rain falling from the sky and filling lakes and rivers on the moon's surface. Titan is the only moon in the solar system with a thick atmosphere, as well as the only other planetary body with rivers, lakes, and seas. Unlike on Earth, the liquid on Titan's surface is made up of hydrocarbons such as methane and ethane rather than water. Its atmosphere is dense with haze, which obscures the visible light reflected off the surface. For years, scientists had hoped to utilize Webb's infrared vision to investigate Titan's atmosphere, particularly its unique weather cycles and gaseous composition, as well as see through the haze to examine albedo characteristics, bright and dark patches on the surface. Titan's atmosphere is fascinating, not just because of its methane clouds and storms, but also because of what it may teach us about Titan's history and future, including whether or not it has always had an atmosphere. After studying the data for hours, the preliminary findings were simply extraordinary, as they observed not one, but two clouds. The discovery has significant implications for our understanding of the moon and its potential to support life. The observation was made using the telescope's near-infrared camera, which is able to see through the thick haze of Titan's atmosphere. The camera revealed bright patches on the surface of the moon that were consistent with exposed water ice. The presence of water ice on the surface of Titan is significant because it indicates the potential for liquid water to exist beneath the surface. Liquid water is essential for life as we know it, and the discovery of water ice on Titan raises the possibility that the moon could support some form of microbial life. The next step for scientists will be to study the water ice patches in more detail and to search for other signs of potential habitability on the moon. The James Webb Space Telescope launched in 2021, and its powerful instruments allowed scientists to make even more detailed observations of Titan and other bodies in our solar system. The discovery of water ice on Titan is just the latest in a series of exciting discoveries made using the James Webb Space Telescope, and it has the potential to change our understanding of the moon and its potential to support life. Titan is the largest moon of Saturn, and it is the only moon in the solar system with a dense atmosphere. This atmosphere is mostly made up of nitrogen, with a small amount of methane and other trace gases. One of the most striking features of Titan's atmosphere is the presence of clouds. These clouds are made up of methane and other hydrocarbons, and they are thought to play a key role in the moon's weather and climate. The James Webb Space Telescope will be able to study these clouds in unprecedented detail. Its advanced infrared capabilities will allow it to peer through the thick haze that surrounds Titan and get a clear view of the clouds. The telescope will be able to track the movement of the clouds and measure their properties, such as their temperature, composition, and altitude. This will provide valuable insights into the processes that drive the weather on Titan and how they are affected by the moon's seasons and its distance from the sun. But how was James Webb able to collect these data sets and make these observations? The James Webb Space Telescope is equipped with a suite of advanced instruments that allow it to make observations of the solar system and beyond. These instruments include the near-infrared camera, the near-infrared spectrograph, and the mid-infrared instrument. The near-infrared camera is the primary imaging instrument on Webb and is used to capture high-resolution images of objects in the solar system and beyond. This camera is particularly useful for studying objects in the infrared spectrum, allowing it to see through the dust and gases that can obscure them in the visible spectrum. The near-infrared spectrograph is used to study the composition of objects in the solar system by analyzing the light they emit or reflect. This provides Webb with valuable information about the chemical makeup of these objects and helps it to understand their origins and evolution. The mid-infrared instrument, or Miri, is used to study the atmospheres of planets and moons in the solar system. It will be able to detect the heat emitted by these objects and provide us with information about their temperatures and conditions. Overall, the instruments on the James Webb Space Telescope provide us with a wealth of new data about the solar system and beyond. And this suite of advanced instruments provides scientists with intriguing observations of Titan. Using these instruments, the telescope was able to track the movement of the clouds and measure their properties, such as their temperature, composition, and altitude, providing valuable insights into the processes that drive the weather on Titan and how they are affected by the moon's seasons and its distance from the sun. After only a few hours of analyzing the data from Titan, researchers quickly determined that a bright light observed in Titan's northern hemisphere was in fact a massive cloud by comparing several photos obtained by Webb's near-infrared camera, NIRCam. Soon scientists discovered a second cloud. Detecting clouds is interesting because it verifies long-held computer model projections about Titan's climate, which predicted that clouds would develop easily in the mid-northern hemisphere during late summer when the surface is warmed by the sun. Researchers thought it was critical to determine if the clouds were moving or changing shape, since this may disclose information about the airflow in Titan's atmosphere. So they swiftly contacted colleagues to seek follow-up observations that evening at the Keck Observatory in Hawaii. The purpose was to investigate Titan from its stratosphere to its surface in order to capture the clouds seen by Webb. The observations were fruitful. Scientists were worried that the clouds would be gone when we returned to Titan with Keck 2 days later, but to their surprise, the clouds were still there, although in different shapes. That alignment, however, does not necessarily imply that Keck observed the same clouds as JWST. Scientists predicted strong cloud activity since Titan's northern hemisphere is in late summer and absorbing more solar energy. Thus, Keck's clouds might have developed recently. And the scientists aren't done with the data yet. The clouds were discovered in photos acquired by JWST's near-infrared sensor, NIRCam, a powerful camera that can image an object in multiple distinct wavelengths of light, allowing scientists to separate out Titan's lower atmosphere. However, the researchers haven't yet completed analyzing all of the data from NIRCam, and a second device was also in use. Spectra were collected using the observatory's near-infrared spectrograph, NIRSpec. This approach divides the light reflected off surfaces such as Titan's atmosphere and evaluates how much of each wavelength is there. The spectra could help scientists figure out what molecules exist in the lower atmosphere, including an unusually bright patch near the moon's south pole. According to the Webb team, JWST will return to Titan in May or June of 2023, this time utilizing its mid-infrared instrument, Miri, which will improve scientists' knowledge of the molecules in the moon's odd, hazy atmosphere. Titan observations are especially crucial today during a gap in spacecraft visits to the cold moon. One of the key goals of the James Webb Space Telescope's observations of Titan will be to search for signs of prebiotic chemistry. Prebiotic chemistry is the study of the chemical reactions that could have led to the emergence of life on Earth. On Titan, the conditions are similar to those that existed on Earth before life emerged, so it is possible that the moon could be a good place to search for prebiotic chemistry. The James Webb Space Telescope will be able to detect the presence of complex organic molecules in the clouds, which could be a good sign of prebiotic chemistry at work. In addition to studying the clouds on Titan, the James Webb Space Telescope will also be able to observe other features of the moon's surface and atmosphere. It will be able to detect the presence of lakes and oceans of liquid methane and ethane, and it will be able to study the moon's geology and geochemistry in great detail. So what do you think about the observation of Titan by James Webb? What important questions would you like to have answered by James Webb? Let us know what you think in the comment section below and share the video with your friends.